So today we'll discuss about even and odd functions. So how do we define a function to be an even function and how do we define a function to be a odd function? So first let's define it. So we call a function as an even function if we replace the value of x by minus x, and we will end up with the same function. If it means that if we are changing the value of x to minus x, there is no change in the function, but we are getting the same value. So a function f of x is said to be even if f of minus x is equal to f of x. This is basically the mathematical way of checking it. Okay, you replace the value of x by minus x and check what happens to the function. If you end up with the same function, it means the function is even. Okay, so it shows that the function value for a particular negative value of x is the same as for the corresponding positive value of the x. Okay, graphically we can find out a function is even or not if the function is symmetrical about y-axis. For example, if you see this function, if you look at the graph of this function, this is the graph of the function fx is equal to x square, and I believe you know how to draw graph for this function fx is equal to x square. We say that this function is even because if I replace x by minus 2, what I will get? In place of x, if I replace here by minus 2, what I will get? Minus 2 to the power 4, which is 4 plus 4, which is same as if I replace x by 2. So negative of 2 didn't change. Also, if I replace f by minus 3, I'll get 9. So in general, if it is say f of minus x, what we can write? Minus of x power 2. Now minus sign 2 times become positive, so we get x square, which is nothing but our original function f of x. So we proved that f of minus x is equal to f of x. That's why this function is an even function. And graphically we can see that if suppose this is y-axis, this is x-axis, and we draw the function curve of the function like this, y-axis symmetrical about y-axis. If we look at this along this axis, so what we can say, this part is symmetrical about this y-axis. Okay, it means if suppose this is a piece of paper and if you fold it over here, this curve overlap this curve. So that's why we say that it is a symmetric about y-axis. Another example, if we consider the graph of the function cosine of x, we know that this is the curve for cosine of x. We say that it is an even function because cosine of minus x is equal to cos of x. This is the property of this trigonometric function cosine of x. So we say that f of minus x is equal to f of x, hence it is an even function. Moreover, we can prove these things by the graph. If we look at on the both sides of the y-axis, it is symmetrical. This curve is symmetrical about y-axis, or you can say that if you place a mirror over here, this is the mirror image on the other side. Next we define odd function. A function f of x is said to be an odd function if f of minus x is equal to minus of f of x. That is, the function value for a particular negative value of x is numerically equal to that for the corresponding positive value of x but opposite in sign. Means the positive value of x is f of x and opposite in sign means the negation of the sign will be there. Okay, graphically you can say that a graph of an odd function is symmetrical about origin. Like in the previous one, it was symmetrical about y-axis. This is symmetrical about origin. So this is an example. fx is equal to x power 3. So let's see the graph. This is the graph of the function. Again, you can use any software to prepare this graph. Okay, or you can simply substitute different values of x. You will get different values of y and you can easily plot it. Now, what you can say, if this is the origin, this is the origin. if you just can say that this is symmetrical about origin, because this is the curve above origin and this is below origin. So it's just the symmetry about the origin. Now, how do we prove that it is an odd function by using this relation? See, for one thing we can do is we can select some specific values and prove that it is coming negative. But in general, what we can do, we start with f of minus x. Put it in here. Minus of x power 3, which is same as minus 1 to the power 3 and x to the power 3. Now minus sign 3 times gives you minus 1 x power 3, that is minus x power 3, and x power 3 positive is the function f of x. So we say that f of minus x is minus of f of x. That's why this is an odd function. Another example is sine of x. We know the property of this trigonometric function sine of x, that sine of minus x is minus sine of x. Okay, so we say that this is a odd function. Also it is symmetric about origin. We concluded that for an even function, f of minus x is f of x and the graph is symmetrical about y-axis. Whereas for an odd function, f of minus x is minus f of x and it is symmetrical about origin. Okay, these are the points to remember. Now, suppose you have this one. The graph of the function is given to you and you need to tell that whether the function is even function or it's an odd function. So now as graph is there, you need to identify even or odd by using the symmetry. Check it is symmetric about y-axis or about origin. Then accordingly you will say that it is an even function or an odd function. So if you look at the pattern of this curve, first we check is it symmetric about y-axis. So symmetric about y-axis means from this line, from the y-axis, if we look this, these two should be same. Okay, symmetrical, it's not symmetrical. But if you look at the origin, means along this, if you look at the symmetry about origin, so what you can see, check the behavior. It is symmetrical about origin. If you see the behavior, see this behavior, it's going up and then down. Whereas it is down, up, down and then this like this. So this is symmetrical about origin. So if it is symmetric about origin, it is an odd function. So this is how we can say it is an odd function, because it is symmetric about origin. So once it is an odd function, we know that f of minus x is equal to minus of f of x. So you can even check the values of the function, like say we have to prove this thing, f of minus x is equal to f of minus 2. Now we have the value at pi, minus 2 pi and 2 pi. So check the value at pi. The value of function at x equal to pi is this value, which is 2. What is the value at minus pi? This is point minus pi, x is equal to minus pi. The value is here, which is minus 2. Okay, so here we can say that f of minus pi, which is minus of 2, 2 is f of pi. Okay, similarly, if we look at the value at 2 pi, the value at 2 pi is 2. Value at minus 2 pi. At minus 2 pi, the value is minus 2. So again, we conclude from this is that f of minus 2 pi is minus f of pi. So we can conclude that f of minus x is equal to minus f of x, because this pattern continues, hence the function is symmetrical about origin and hence the odd function. Now let's look at this example. So let's first check the symmetry about y-axis. So if we look at the y-axis, this is symmetrical about y-axis. So we say that it is an even function. because it is symmetrical about y-axis, and also that f of minus x is equal to f of x. For that we can work in the same basis, like if I say f of pi by 2, I know the value at pi by 2 is 3. What is at minus pi by 2? Again 3. So which is same as minus pi by 2. So it satisfies this. Let's check at pi. At pi and minus pi, f of pi is 0, which is same as f of minus pi. Okay, so hence the value is same. Similarly, this value will be 3 pi by 2. The value is here again 3, and it's symmetrical about x-axis. Can also check the value at 0. It is 3. So it is an even function. What about this one? This is symmetrical about x-axis or y-axis. Sorry, symmetric about y-axis or origin. So if we look at the symmetry for y-axis, so if we move towards the right side of y-axis, the curve is like this. But here there is no curve, it is going downward. So it is not symmetric about y-axis. Also, it is not symmetric about origin. So in this case, this function is not symmetric about x-axis, neither symmetric about x-axis nor about y-axis. Okay, so let's confirm these things by doing the calculation. So let's check the value at pi, the value of the function at minus pi, the value of function at 2 pi, the value of function at minus 2 pi, because these are the points given to us. Okay, at pi, what is the value of the function? It is 0. At minus pi, again it's 0. At 2 pi, this is the value. Okay, this thing is not working. So if we check just the values at the endpoints pi and 2 pi, this will not work. If we check some middle value here, check the value is given by this line. Whereas if we select any value here between, see, this is the value from pi to plus 2 pi. So we have to take the similar value over here. Minus pi to minus 2 pi. So the value is given over here. It is a constant value, whereas here the value is changing. Okay, it is not it's changing as per this line, whereas here in this interval the value is constant. So therefore this function is not satisfying the properties that f of minus x, it is not equal to f of x, nor f of minus x is equal to minus f of x. So we say that this function is neither even nor odd, because it is not symmetrical about either y-axis or origin. Okay. Now we'll go to the properties of odd and even function. Now let's talk about the products of odd and even number. So whenever we multiply two even numbers, even functions, you will get again an even function. And when you multiply two odd function, you will get an even function. But if you multiply an odd function and an even function, you will end up with an odd function. It is similar to how we multiply the signs. Like if I represent even function by plus, odd function by minus, we know that plus multiply plus gives you plus. Minus multiply minus means 2 times negative gives you positive. And if it is 1 positive, 1 negative, it gives you negative. So these are the rules for the products of odd and even function, which can easily be proved. See, if we consider the product of two even function. Okay, say f of x is product of two function fx and g of x, small fx and small gx, where these are even function. Then to check that the product is even or odd, what we will do, we will replace this x by minus x. So what will happen? When we change this x to minus x, we have to change this x to minus x as well as this x to minus of x. Okay, now since it's given that fx and gx are even function, it means f of minus x is same as f of x, and g of minus x is same of g of x because both are even. So in place of f of minus x, we will replace f of x. In place of g of minus x, we again replace g of x, which gives you the original function f of x. Hence, we prove that f of minus x is equal to f of x, where fx is a even function. So this is how we prove that product of two even function is an even function. Okay. Now, similarly, if we want to prove that product of two odd function is an odd function, again we consider the same thing. Capital F of x as product of two function fx and gx, where both are odd function. Now here it is odd function, so it means f of minus x is equal to minus f of x. And we say that gx is an odd function, then by the definition, g of minus x is equal to minus g of x. Now, let's consider f of minus x. So, again what we did, we are going to replace x here, we replaced by minus x. So, we have to replace the corresponding x here as well. So, it become minus x, minus x. Now, we use this property. This is minus of f of x and minus of g of x. Now 2 times minus become positive. So we left with fx gx, which is nothing but the original function. And hence it's proved that fx is an even function. So this is the journal calculation how we are working on it. So it means if I replace fx and gx by any function, you can work on it. What do I mean is, like suppose I'll give you say fx, or let's use the capital F of x. If we replace, if we say that if capital F of x is say x power 4 cosine of 2x, and we want, sorry, this is the example for the previous example, two even function. Let me give it over here. Fx is equal to say x power 4 cosine of 2x. So let's assume this is your function fx, this is your function gx. So fx is equal to x power 4, gx is equal to cosine of 2x. Now we need to check if it is even or odd. So f of minus x is minus x to the power 4. How many times negative sign? 4 times. So it becomes positive. It gives you x power 4, which is your function f of x. So we got f of minus x as f of x. So this is an even function. Similarly, if I consider g of minus x, it is cos of minus 2x. And we know that in the cosine, the negative sign is absorbed. So we can say that this is g of x. So again, g of minus x is equal to g of x gives you even function. So product of two even function is an even function that we can prove here. See, x power 4. You can either prove that since fx is product of two even function, therefore fx is an even function, or you can directly do the calculation here. There are two ways: f of minus x power 4 cosine of minus 2x. So this is x power 4 cosine of 2x, which is same as fx. So it also turns out to be even function. So we can work in the same way for any function. So here when we are able to work with the generalized function, it's easy to work with the particular case of the function. Like here, let me just make it odd function. If I say x power 3 sine of x, so we know that x power 3, this is an odd function. Sine x is again an odd function, because minus of x power 3 is minus x power 3, and we know that sine of minus x is minus sine of x. So these both are odd functions. So we can check it here, f of minus x. We can either write As it's product of two odd functions, so it is an even function. To prove that, we write minus x power minus 3 sine of minus x. So here the negative sign comes out, it becomes minus x power 3, and here minus sine x. Minus minus become plus, x power 3 sine of x. This gives you f of x. Hence it proves that it is an even function, because f of minus x is f of x. Now similarly, we can prove that if we multiply one odd function and one even function, we will get an odd function. So let's say fx is a product of two functions where fx is odd, it means f of minus x is minus f of x, and gx is even, it means g of minus x is equal to g of x. Then when we replace minus x by minus x, we'll get this and we'll end up with the negative sign. Hence it proves that product of one odd and one even function is an odd function. Like for example, if I say fx is equal to say x cosine of x. Okay, so I will say that let it be the function f of x and this be the function g of x. So fx is equal to x. What is f of minus x? This is minus x, which is minus of f of x. Hence it is an odd function. And gx, which is cosine of x, g of minus x, cosine of minus x, which is nothing but cosine of x, means gx. Hence it is an even function. So when we talk about f of minus x, this is replace x by minus x, cos of minus x. So this will be minus x and cosine of x. So this gives you minus of f of x, because this function is nothing but the f of x. So hence it is an odd function. So if we see in the first question, x power 2. So it is an even function. Sine 2x, this is an odd function, because sine function is odd. So even multiply odd gives you odd. Here, this is odd function, this is even function, because x power 3. So cubic is an odd function. So this is again an odd. Cosine, we know that cosine function is an even function. So cosine, it doesn't matter angle is 2x, 3x or 4x, it will be even. Here, x we know that odd function, sine also we know that odd function. So odd multiply odd gives you even. Similarly here, sine is an odd function, cosine is an even function. Odd multiply even gives you odd. Okay, or sometimes like if you don't want to do it in this way, what you can do, say fifth example, you write your function fx as 3 sine of x cosine of 4x, and we want to check if it is even or odd. So for that, simply replace x by minus x. So what we will get, 3 sine of minus x cosine of minus 4x, right? We know the property of sine, it is 3, it is a negative sign, it will come outside, minus sine x. For cosine, we know that it absorbs the sign, so it is cosine of 4x. So now we keep the sign in the front, minus 3 sine x cosine of 4x. Now except the sign, if we look at this term, this is nothing but our same quotient f of x, right? So here we can say that this is equal to minus of f of x. So what we proved, f of minus x is equal to minus of f of x. Hence it is an odd function. Okay, so this is odd function. This is how we do the calculation. Or we can do it in another way, like we just say that this is odd function, this is even function, prove them separately, and then say that product of odd and even is odd. Now look at question number 6. Now let's look at question number 6. This is say fx is equal to 2x plus 3 and sine of 4x. If I replace x by minus x, so if I replace x by minus x, what will happen? It will become minus 2x plus 3, and here sine of minus 4x. Now if we look at here, we cannot take this minus sign outside, because if we take the sign outside, it will become minus 3 here, 2x minus 3, which will be different than the question. So let's keep this term as it is, and here, as the property of sign says, we can take the sign outside, 4x. Okay, so it becomes negative of minus 2x plus 3 sine of 4x. Now if we look at here, what is happening? Sine of 4x, okay, same. We got the same function. But here we didn't. In the second one, if we look at this term, this is not same as this, neither the negative of this. Like even if I multiply this minus sign inside, let's say if I multiply this minus inside, then what will happen? Minus minus become plus, so 2x minus 3, which is again different than this one. So in this case, when we are replacing x by minus x, we are not able to get, say, we are not getting f of minus x, it's not equal to f of x first of all, as well as f of minus x is not equal to minus of f of x, because we are not able to get the original function because of this term. So we say that this is neither even nor odd, and you can identify this thing from here. See, we know that sine is an odd function, but here, as there is a constant added over here, this is neither. That's the reason you are getting neither even nor odd. We can see here sine square x, this is even function. See, power 2 comes, so even function. This is even. Even become even, because we know that sine square x is same as sine x power 2. So we know that this is an odd function. An odd function power 2 becomes even, because odd multiply odd gives you even. So product of two even function becomes even. Here this is odd function, exponential function. If I replace x by minus x, I will get e power minus x. So it is neither even nor odd, so it again neither even nor odd. In the same way you can work with this. Now this is cos hyperbolic function, okay, with this as an argument. That's it.